Welcome everyone. Welcome to the sixth lecture of our LLMOPS series. We are at the last video of our series, and this is going to be a very important and interesting video. Till now, what we have done, we have basically completed our full module. We have integrated it with the client, like the front end, using the APIs we have created using FastAPI, and even we have created some tests to be run and all. But the important thing is, how will the user will gonna access our app? How are you able to make your wonderful application you have created accessible to the whole world? How you will do it? You have to deploy it in a particular server. So we are gonna do the same in this video. That we are gonna deploy our application we have created into AWS. We are going to use some specific entity of AWS, which I will tell you further in the session. And also we are gonna do it. Also we are gonna do it by creating a proper CI/CD pipe. Okay. So that was the overview of the session. Now let's move on to the session's agenda, that what we are going to focus on, and let's get started. So as you can see, we have 5 main session agendas in this session. The first is understanding CI/CD pipeline. That we are going to create CI/CD pipeline for our deployment. What is CI/CD pipeline? I will come to that in a minute. That is a very important and very productive thing for a developer to do, and for a team also. The second thing is we are going to understand GitHub Actions. What is GitHub Actions? If you are not familiar with that, it is gonna be magical for you. Like you are gonna save so much of the time by using GitHub Action. This is a DevOps type stuff, but you should also know that if you are a LLMOPS engineer or a GenAI engineer. And the third thing is, after understanding the CI/CD pipeline and GitHub Actions, you are ready to integrate CI, like continuous integration workflows, in your project. And the fourth thing is we are going to understand now we are going from the fourth step we are going to move to the deployment step. In the first three steps we are understanding the CI, continuous integration steps. In the fourth and fifth agenda we are going to understand the deployment part. Okay. So I will get the overview of that in the upcoming session, that what is this ECS, what is this Fargate return, and how we are going to deploy it. Okay. So one note here, you are going to need a AWS account. So please be ready with it. I have also told you to do that in the previous session, that please be ready with your AWS account. AWS account creation is pretty easy. You just need a credit card, and you have to verify using your ID, like like Aadhaar card and all. So you can make a free tier account in your AWS. You get a free credit, and the free credits are sufficient for this deployment. And you will not gonna exhaust your free credit limit. That will only cost 1 to 2% of your free credits. So please set up your AWS account, and let's get started and understand what is CI/CD pipeline. Okay. So let me tell you by an example that why CI/CD is important and why would you use it. Okay. So for example, in the previous session, what we have done, this is our repository, okay, in which we was working, and what we have written in the previous session, we have written this test, right? But how we are running it? We are running it like we are typing this Pytest here, like Pytest here, and the Pytest is running. But the problem here is that will you run this Pytest manually? Like you will make hundreds of changes in the upcoming future in your project, and will you run, and you have to run test every time, like you have to run your unit test, your integration test every time you make some changes, so that you ensure that the previous functionality are not broke, and your project is working fine. So is it a good way? Is it not is it will it be better that it will be automated, that okay, my test should run every time I integrate something? So the same thing, the automation can be easily possible using the CI flows, like CI/CD pipe. So the main thing is that the CI/CD provides us a very pretty nice way to automate your workflows, which you do like which you do the same thing again and again. Okay. So let me explain you that with a set of example, like using a flowchart. Before that, for example, what use case we are taking to understand this, we have written this test, okay, and our goal currently is to automate this process of again and again running this test, again and again running this test after every change I have created. So we create a change, like we create a new change here. For example, this was your main branch, okay, in which you was working, okay. How can I explain? Yeah. So wait a minute, let me create a line here. Yeah. So this was your main branch, which was your working. And but what you have done, you have created another branch, another feature branch here. Like you have created another feature branch, okay, which was like feature one. This is how we work, okay, feature one, okay. But you have integrated a feature one. Now what you want that, okay, I should run my unit test. I should run all the tests I have written, and I should ensure that all the tests should pass, and then only I should push it into the main branch. Like I should push this feature into the main branch, and even after, like for example, I have pushed it into the main branch. Even after pushing it into the main branch, I should run some tests. Okay, firstly, after integration, when I open this PR, like when I open this PR pull request, okay, this is what it is. It is a pull request. I should run a test, like okay, please run all the tests. Run all tests. Okay, this is the first step here. But after opening the PR, and for example, if someone approve it. What is approval means? Approval of PR means. What is approval of PR means? It's basically saying that someone in your team or you itself are saying that okay, the code is looking fine at my glance, at my review, and I am approving that okay, the feature one will integrate properly in this main branch, in the code which is present in the main branch. So once I close this PR, like I approve this PR, approve this PR, approve this PR. I also want that okay, I should run all my tests again, because I should know, I should get to know that okay, in the main branch all the functionalities, previous functionalities I have created, that is working fine, and the new with the new feature I have integrated. So I also want to run this test again. Okay. So what are main agenda of this CI of this CI understanding of CI pipeline, and what we want to do in the first half of the session, that we want to integrate this. Like for example, when I created a PR, when I create a PR, when I open a PR, I want to run all the tests. And when I approve this PR, and when I successfully push the features code into a main branch, I want to run the test again. So we are gonna automate this. Okay. So for this, I want to explain you the CI and CD. Like what is CI and what is CD? Firstly, CI stands for continuous integration. Okay, and CD stands for continuous deployment. Okay, so what is continuous integration? I want to explain continuous integration with the example of this content. So for example, you are creating a data science project, and okay, and you have story A, story B, story C. Like what is story A, story B, story C? Story A is like feature A, story B is like feature B, and story C is like feature C. Okay, and you and your friend is working on it, and you are working like okay, this is the main branch, this is the main branch in which your main code will be written, and which is the final code, like which is the final version. But what you want to work on story B, story A. For example, me and you are working together on a project, and I am working on a story A, and you are working on a story B. So how you and I will work? I will take a pull. I will take a pull. I will check out a new branch from a from the main branch. Okay, and I will name this branch. What I will name this branch? I will name the branch story A branch. Okay, and what you will do? You will also take a pull from this main branch and check out a new branch which will called story B branch. And I worked on this story A branch, and you also worked on this story B branch. Okay, and a final case come when you say okay, my work is done. For example, I said my work is done, and I want to push it into the main branch, that this story A is completed. Means feature A is completely built, and I want to push it into the main branch and see that everything is working fine. So what I will do? Firstly, I will build some test cases on my own. That okay, my this test cases must pass before I push it into the main branch. Okay, I merge it into the main branch. So I will write all the test cases by myself, and I will build the project on my own, the story A version of the project on my own, and I will test on my end on this branch particularly that okay, everything is working fine. And when I merge it, I also want that this test cases, like the test cases which are written in this main branch code, will run, and the test cases which are written in this story A branch will all will merge, and all the test cases will run, and we will see that if anything is failing, and we will improve on that. And similarly, you will complete your work, you will build some test cases, you will write some test cases, you will build your project, and you will test on your basis. And when you are like you are want to create a PR, and you will merge it, all the test cases written in the main branch will run again and check that okay, all the test cases which are present in the main branch will run, and all the test cases which were written will run, and ensures that everything is working fine. So this is the way how a team works on a project. And the CI, like and this is what is called continuous integration. Like continuously we are integrating that okay, story A is continuously integrating with the main branch, story B is continuously integrating with the main branch, and we are continuously testing and creating and testing all the use cases and all the things. Okay, and we are also resolving the conflicts also. So this is a continuous process. That's why, and this is an integration of all the features into the main project in a proper manner, in a robust manner, so that we can ensures that our the code in the main file works fine with all the integrations we have. So this is what it's called continuous integration. And how to do this continuous integration in our projects? So majorly all the developers like work using Git. Okay, and we know that GitHub, in the GitHub we uploads our repository. Okay, so GitHub provides a GitHub Action server, which provides us the way of doing continuous integration and continuous deployment in our project. So GitHub Action is the thing which allows us to do continuous integration and continuous deployment. Okay, so I explained you what is continuous integration. Let me explain you what is continuous deployment. So what is continuous deployment? Continuous deployment is like, okay, we have created this main branch and we have integrated this story A and story B. But will you directly give this main branch to the end user? No, right? You want that all the features you have created, all the code you have integrated in a main branch works fine. Like you want it to work at the you want to ensure that there is not a single bug, okay, in your integration in your software. So what you will do, you will create stages in your deployment. Like you will first deploy it in a dev environment. Like you will first deploy it to dev environment, and you will check, okay, there is an error, if there is any error on your behalf. And what you will do, you will deploy this repository. After dev, you will find some bugs and all. You will do the testing of that. You will find the bug, and you will again make some changes in your core GitHub repository. Okay, and then what you will do, you will again deploy it, give it to your QA team. So what you will do, you will give the changes, the bugs you have resolved on the system, on the unit and integration level, and you will give it to the QA team. And what QA team will do, QA team will again deploy it in a QA environment. Like they will deploy that thing in a separate server entity, and they will check on their behalf. For example, they check about the system testing. They test that, okay, the whole system is working fine or not. Is there any system level bugs? And if there is any system level bug, they will give you the feedback. You have to make some changes, and then the project is ready at the QA level. Then the main code, the main project of yours will go into this UAT and deployment. The UAT team will deploy the project, and they will check for any major bugs and all. They will check for any minimal bugs and all. They will check your application from every perspective, from the user perspective and all, from the requirements perspective, from the story perspective. And then the UAT team will, okay, approve that, okay, this repository will is good. And if it is not good, they will give you some feedbacks. So you have to integrate it, and then finally you will deploy it into a production environment. So as you can see, there is multiple stages of deployment, and this is continuous process. Like firstly you give it to dev, then you give it to QA. But for example, QS gives some feedback. Then what you will do, you will again deploy it into dev. You will check on your end. Then you will give it to QA. Then QA test again. So you want multiple deployments, and this is a continuous process. So this is called continuous deployment, and this is also possible using the CI/CD pipeline and GitHub Actions. Okay, GitHub Actions, and there is also other players like Jenkins and all, that is also used, and Bitbucket also provides one. So this is the thing, like CI and CD, like continuous integration and continuous deployment. So we are gonna we are not gonna deploy our project only into the AWS. We are gonna deploy the project in a CI/CD manner by creating a CI/CD pipeline. So I hope you got the gist that what is a CI/CD pipeline. And now let's understand the basic working of GitHub Actions. What is GitHub Actions, and how to write GitHub Action code, so that we can integrate our project into GitHub Actions to run CI/CD pipelines. So we are firstly going to focus on CI workflows, creating CI workflows. So firstly, let me tell you where you will find this GitHub Actions in a GitHub. So for example, I have found opened this GitHub. This is my repository, and I opened this particular series repository. Okay. So you can see there is this tab which is called Actions. So in this Actions, you will find all the current actions, like actions. GitHub basically calls all your CI/CD pipeline code as a workflow, and you will find it inside the action. So action is basically a server which is provided by the GitHub to run all your workflows for CI/CD related code. Okay. So for example, I have already tested the CI/CD using before the session for preparing this session. So this is giving me all the workflows I have run. Okay, so you will find here, but you can also find all this. This is a marketplace of the workflows. This is a some pre-made, like the template workflows, you can say, which is already created. Because for example, you want to install your dependencies, you want to set up your Python. So you will not write this setting up Python workflow again and again. You will just get it. You will just copy this setting up a Python application, like create a test a Python application workflow, and use it as it is inside your workflow file. So how we will do it, we will see in a bit, in a few minutes. So please be with me for that. And so here you get, this is like a marketplace of workflows which is already created. You can use it and write your workflow code in a productive manner. This is like a bootstrap of workflows, you can say that. Okay, so now let's understand that how to write the GitHub action code and where to write it in our project. So let's move on to the our project repository, our project file ID. And here what we have to do, we have to create a directory which is called .github. This is mandatory to name this file, this directory as .github, because by naming it as .github, the GitHub will know that okay, the CI/CD workflows like the GitHub action workflows will return inside it. Okay, and then we have to create a workflow directory here, workflow directory here, workflows. Uh, be be concise, be concurrent with the name I am creating, because this is important. If you named it incorrectly, for example, you named it workflow, then it will not work, because this is important. The naming convention here is important. Okay, so let me check in again. Workflows. Okay, this is good. And now what I will do, I will create a YAML file here. So you write your workflows in YAML file. Okay, so I will create a ci.yaml file. Here is the ci.yaml file. So here we have created a ci.yaml file. And what is ci.yaml file? It will contain all the workflow related code for continuous integration. So let me explain you how to write a workflow code. So let's understand it one by one, that what is actually happening here. Okay, so let's take a screenshot of that and let's go to the flow and let's understand it, what is happening. Okay, so here is our screenshot and let's understand what is happening. So firstly, what you are writing, what is a YAML file? YAML is just a key value pair file. Okay, you have to define key value pair in an indentation form. So that is a YAML file. So we are just configuring, we are just telling the GitHub Actions server that okay, run the CI workflow in this manner. So how the GitHub Action will know? The GitHub Action server will look into this ci.yaml file which is present inside this .github/workflows. So that so the GitHub Action server will know that okay, I have a workflow to run which will name that CI, which will be contained in the ci.yaml. For example, you want to create another workflow, you just create another file which is, for example, cd.yaml. Okay, so this cd.yaml will contain the continuous deployment related workflow code. Okay, so for that is not a currently we are not doing it, so I will delete it. So this is that. So what we are, how to write the configuration code? So firstly, you define the name of the workflow. Okay, what you will do, you define the name of this workflow. What is this? So what is this? This is just the name. Okay, this is the name. Like you are defining, okay, this workflow will be named as CI. I can name it anything. I can name it Yash. I can name it LLMOPS. I can name it anything. It is up to yours. Okay. And then what we are writing on. What is this on? This on is like event. Like on which events, like this on is like saying that on which events I want to start this workflow. So what is an event? Event is like the actions you are taking on your GitHub repository. For example, you are checking out a directory, you are pushing a directory into pushing a branch into another branch, you are making some commits, you are creating a pull request, you are closing a pull request. So that all will contain some, that all is called events. So here we are defining that on which events. Here in this on is like defining on which events. Okay, on which events I want to run this workflow. Okay, so this is creating like that. Okay, and on which that I am saying that okay, please run this workflow, run this ci.yaml configuration on every push on the main branch and on every pull request created on the main branch. Okay, so I hope it is clear. So this on will tell you that on which events I want to run this workflow, and you and on this, inside this you will define it on the push and on the pull request, and you can also specify it on the push of this push done in the main branch, on the pull request done in the main branch. You can also write dev also here by writing a comma. So on the pushing of the main and dev, this workflow will run. So here defining that when I want to run the workflow on which events. Now what is written, that here is a job, like what will be worked in this workflow, what jobs will be done in this workflow. So this job will give us, like actually what to do in this workflow. Okay, so this is like creating the set of actual actions which the GitHub server should take on the happening of these events present inside this on key. Okay, so we are creating jobs. This is called jobs. So this is our first job. What is our first job? This is our first job. Okay, this is our first job. And here I can also create another job like test 2, for example, or I can create like test unit test and then integration test. There's 2 jobs. So I can create multiple jobs inside this jobs key. Okay, so I am defining this test job here. Then what I'm saying here, I'm saying that okay, run this inside Ubuntu latest, run on inside Ubuntu latest. I can also specify that the GitHub Actions server provides us another images like here Ubuntu is used. You can also use Windows, you can also use Mac OS. So that is also possible. And now what is this steps is like what steps I need to take to execute this particular test job. So I'm saying that okay, this name of this step is checkout, and I am using this action slash checkout at the rate v4. What is this? This is using the template workflows which we have seen in the marketplace, which we have seen of the GitHub action server. So here we are saying that okay, use this checkout at the rate v4 workflow as it is inside this step of the test job. So we are what we are doing, what this checkout v4 will do. This will check out our repo in the server of git server of actions. Okay, GitHub actions. Okay. And similarly, what is happening here? Here we are naming a step like here we are naming it setup Python, and we are using this pre-made template workflow, which is saying that okay, set up this Python for me, and we are specifying the version like okay, the version of this file is 3.12. And again, what we are doing, we are just doing the same thing which we are do to set up a Python project. So we are setting up the UV. We are using this set of template command to set up the UV. And that's what is this at the rate v4 v5. This is the versions of the template which are created inside the marketplace. So we are saying directly pointing out to the version 4 here. Like here we are pointing out to the version 5. So what is the next step after setting up the UV? We will install the dependencies. So we are doing the same here. Like we are syncing the dependencies with the UV. Okay. So this name and what we will run in this step, we will just run this command UV sync frozen UV pip install pytest. So we are doing that, and then we are running the test by we are configuring the environment properties here, like we keep the bypath and API keys as dummy and all according to the test configuration environment we have done in the conf test file in the previous, and we are just running this command like uv run pytest q. So I hope you got the understanding that what is a ci.yaml file and why we create, okay, and how to write. So now let's push the changes we have created in the repository. Like we have created a ci.yaml and push it into the GitHub and see what it does. Okay. So let me go here, and what is the changes here? Like we can see, this is all the test changes we have created, and this is the ci.yaml which we have understood recently. So let me commit it like wrote test and ci workflow code. Okay. So for example, I have done this, and I will sync it. Okay. So what it will do, it will just commit all the changes and it will sync it. Okay, so I have committed my changes successfully, and now let us sync the code to the origin of the main branch. So our code is successfully pushed, as you can see, and now let's check out the GitHub and see what's happening there. So let's see go to the series repository, and let us see. So what you will notice the difference here in whenever you don't configure your GitHub Actions, you don't see a dot here. Like here is the status of the currently running jobs, currently running workflows in your GitHub Actions server. So here it is showing a yellow dot, so it's showing me a pending status. So as you can see, we can see that the tests are failing. Okay, so this what it does, it run the job which was named test according to a ci.yaml. It set up the job, like it ran the template workflow we have created for setting up the job. It's checkout using the actions that check out the template which we have done, and here it's in the running test, it's give us an error that okay, cannot import global import from logger. So this is a thing, this is a problem which we have done in a code. Like we have missed something to integrate in our code. So what we have missed, we basically imported the logger as global logger, as you can see in all the files. Like not here, wait a minute, let me tell you. So in source, in document chat, in retrieval, as you can see, we have imported global logger as log from logger. But when you see the logger, you don't see any global logger. Why we don't see? Because we have to write the code for importing this global logger. So what we will do? We will define this code. Okay. So where we will define this in this init, and what we will do, just redo it, and custom logger. Why it is not coming? Because the name is, I mismatched the file name. Okay, so this is done, I think so, and from this I am done. And okay, so what I am doing here, I am saying that okay, please make this global logger, please make this a variable which is global logger equal to this instantiation of this custom logger which we have created, and get logger this dunder variable. What is this dunder variable will do? It will take this value will be the value of this name variable, will be the name of the file which is currently calling. Like this logger is called by this retrieval.py file. So the name variable will get the value of retrieval.py file. And for example, this instantiation of this global logger is done inside this data ingestion.py file. So the name logger will get the name of this data ingestion.py. So this is the way. And why we are writing this global logger inside this init.py, because to tell the interpreter, to tell the Python that okay, make this global logger available to the whole modules present inside my project. So for that purpose, we are writing this code. So we have done this, and I hope the code is fixed. So let me write a commit here like fixing. Let me write a code here like fixing uh, logger error. Okay, and then let us sync it. So I've committed the code and I'm syncing the code, and now this is code is committed successfully and synced successfully. Now let us see that we have synced the code, we have pushed the code into another branch. So according to that, a new job will run automatically. This is the magic of GitHub Actions, and our job is running, our workflow is running, and as you can see, it's failed another time. So why it's failed? Let us see. So it's giving us error that okay, pip install fire CPU is not present. So let us install it. Okay, and let us do one thing. That just what we will do, we will just add it inside our requirement.txt. Okay, here we will install CPU, and now let's recommit the changes like added fire CPU. Okay, and let's commit and sync it, and let's see that is everything is working fine or not. So you can see what is happening. We are committing the code, we are committing it to origin, and the testers are running automatically. So this is the main thing. This is the automation we have done using this CI/CD, using this GitHub workflow. So as you can see, I have committed my 7th commit, and I pushed it into the main branch. So that's why this workflow is running. And you can see inside that okay, why this is failed again. So this is failed again because again the same error. Why I'm getting the same error? Let me configure. So we are getting the same error because we have added the dependency inside this requirement.txt, but we are not using pip here. We are using UV. And what UV do? UV in the github.ci.yaml, we have seen that we are syncing. We are using the uv.log. Like this uv.log will be used to install the dependencies in uv sync command. So what we need to do, we need to sync it and it in our code also. Okay, so we are syncing that, and now we can see that our, so what I need to do is I will need to first uv add -r requirement.txt. So it has added the package. Okay, and in our current dependencies like project.toml, and what we will do now, we will just use uv.sync here, and it will update this fires.cpu inside my uv.log, and I will just see that added fires cpu in uv. Okay, and now let us commit sync it. Yes. So again you will see we have made a fresh commit and sync into the main branch. So again a workflow will run, and in this time you can see the job has done successfully because we have resolved the import error, okay, of the main, because we have synced it with the UV. So as you can see, the whole jobs are running, like setting up the UV, the setup dependency with UV. We are running up the test successfully. In this we can see that okay, 12 tests are passed and all, and so we then just run the another job like post job cleanup and all. Okay, so as you can see, this is the productivity system we have created. Like whenever we push any new code into the main branch, all the tests are running again and again, and we are getting continuous feedback. If we have not configured this GitHub Actions, if we have not configured this CI workflow, we have to do it manually. Like we have to run the test manually, and then we are checking it, and then we have to push it, and then we have to check it in some way, like again and again by ourselves. But our ci.yaml automation, like the ci.yaml workflow is handling it our own. So due to the all the errors I've got, you got the understanding that okay, how CI/CD actually works. So we have understood that how to integrate CI workflows in our multi-doc chat. And now let's understand what is ECS and why I've written Fargate here. And what is this basically? So ECS is related to deployment in AWS. Our final step was deployment of our current implementation of our project into a basically cloud. So we are using AWS here, and in AWS we have other entities like EC2, and there are ECS, and there is other things like other ways of deploying your application like Lambda functions and all. So that's why so here we are using ECS. And what is ECS? So to understand ECS, let us go to the whiteboard and understand what the entities you need to know before we start deploying. Okay, so let's go to this flowchart and understand that for deployment we need to first dockerize our application. Like we need to create a Docker image. So what is Docker? Docker is basically defined a structured way. Basically, we What we do when we run an application or we create our project in our Pythons, we basically manage environments, we manage dependencies, and for every deployment, what we do, we basically recreate the whole dependencies and all in the deployment environment. But this is very complicated. Sometimes this gets very complicated. So Docker helps us to do it helps us to basically create an image of our current implementation of the project and run as it is inside the Docker container. So what is this image and what is this Docker container? Docker, let me explain you what is Docker image and Docker container with the analogy of basically computer like PC and our software. Like for example, you have a Mac. Okay, so you have a Mac. So in your Mac, what you run? You run Mac OS. Like okay, you run Mac OS. So this Mac will be like your container. Okay, this Mac will be like your container, and this Mac OS will be an image. So what is this Mac machine? This can be a simple CPU, like for example, this Mac machine is of 16 GB RAM. Okay, and this is a M1 chip. Okay, this is a M1 chip. So this container has this much configuration, this much computing power, but I can run anything in it. Like for example, I can run the image of Windows here. I can run an image of Windows here. It will be a pretty complicated task to run a Windows on a Mac machine, but it can be run. Likewise, I can run Linux here. Okay, so what is this? These are images. These are images which are running on the container, which is analogous to like your Mac computer is running a Mac operating system, or your Windows machine is running your Windows operating system. So Windows operating system is an image, and Windows machine on which the image is running is called a container. So in Docker, what we do, we basically containerize our current project. So in our current project, for example, we have multiple dependencies. For example, we have this Python, then we have the dependency of Fias, and then we have other dependencies like FastAPI. Okay, FastAPI. Then fourth is UVCom. So what we can do, we basically create an image of it. So we basically create an image of it. Okay, and we have a container. We have a container here. And this is a Docker container, and we run this image on this container. Okay, and I can run any image of it. For example, in other project you have UVCon also, this also, and you have other project also, like you use Chroma there, Chroma. So you have this image. You just run this as it is image in the container, and you use this Docker container in the production environment, like in your AWS. So this is the main concept of Docker. So to run your Docker, what you need, you basically need to install Docker in your. So what steps you need to follow to install Docker in your system? I will not show you how to do it, but I will guide that you can do it like that ways. Okay. So what you will do, you will just go to the Docker website and just download Docker system, and then install the Docker, and then just run the Docker in your system by running the exe or the file for or the respective file in a macOS. Okay, and then what you will do, then here what is written, create a Docker file inside your project folder. What here is written, that you need to pull a Docker file from a Docker hub. Like what is a Docker hub? Let us see that what is Docker hub by searching on the internet. So Docker hub, let me take you there. Docker hub. Yeah. So what you can see here, this is a Docker hub, and you can see here is multiple images. Like you can search Python image here. Like here, you can see there is a Python image. So what this Python image will do, this Python image is just a you can say you can run this image into a Docker container, and the Docker container which is running this image will have Python in it. So similarly, you can do other things. Okay, so you can search here and do that. Okay, so likewise, there is other images also. Like you can see, like for example, I want a Linux image. So I will write and I will see some images, and which will basically I can pull and I can use it as it is inside inside our Docker container, and it will have this configuration. Okay, so for example, this Python image. So this Python image, I can go in it, and then I can just directly run it in Docker Hub. So what it will do, it will open the Docker app. It will open the Docker app here, and it will say that pull and run this image. So it will just do this. It is just pulling, like it's like a GitHub repository. Like in GitHub repository, we have repos. Like here, we have images of Docker, and then here it is saying me that give me a container name. So I am here saying that Docker test is a container name. So I'm running it. Okay. So here we can see we have a container that is Docker test. It is running a Python 3.14 image, and I can just run it here, but it is not running because of we have to do some configuration also. So I hope you got the basic understanding that what is it. Okay. Now let's go ahead and see. So what we need to do, we need to create a Docker file. So let's go into our project structure, and let's create a Docker file. So Docker file. Okay. So please use the exact name as I'm using here, because this name will be used by the Docker to run our image. Okay, so Dockerfile. Okay, so here I have done, and I have to provide them commands here. So let me take it and let me tell you. Okay, yeah. So what is actually happening in this Docker image? We are just using this Python 3.112 slim image. What we are telling that, okay, the image we want to build from this Docker file will use a Python 3.1 at the base, and then we are telling that don't this is just an environmental setting, that don't create this cache files. Like you can see this py cache, so I'm telling that no, don't create it. So I'm telling equal to 1, and also some other same configuration. I'm telling that this use this as a work directory, and then I'm installing this OS dependency. Like I am installing this is sudo apt, and I'm installing this essentials like and then I'm installing this essentials like compiler tools we need and all. And then this popular utils is like some basic and popular utilities like for working with PDF and all. So we are already installing it here. And then what we are doing, we are installing UV here. Okay, so in our project we have used UV as a package manager. So we are installing UV, and we are telling that, okay, use this app multi-doc chat as our Python main project directory. And then what we are doing, we are copying the requirements.txt into the Docker container. And then we are just running this UV pip install. We are installing this dependencies mentioned in the requirement.txt, and then we are copying all the projects file. It's saying in copy the current project directory into the current container directory. And then we are exposing this port 8080. What is this exposing port 8080 means? So let me tell you it with a example. Like for example, we have created this Docker container. This is a container, and containers are isolated from the system environment. Like, so this is isolated. So I have created a server here, and I ran it, and it basically port ran on port 8000. But our container is running, but it is not giving us the access. Like it is not mentioned that, okay, where how to access this container, because it is an isolated environment. Like this is a complete machine. For example, I ran a container, but I don't expose a port. So what it signifies, this is my current Mac OS. This is my current Mac machine. In that I ran the container. Okay, but it is isolated. It is not saying anything that to access myself use this port. So for that we need to tell that, okay, to access this port of mine, to access my container, you need to expose some port. So here we have told that, okay, use 8080. So what we are saying, okay, 8080 is a port on which this container can be accessible. So 8080 will be a port. 8080 will be a port by which this by which anyone which is using the image can access this container. And at the end we need to do port mapping while running the containers. Like, okay, this 8080 port is should be mapped to some internal port of my machine. Okay, so what is mapping basically? Like in my Mac OS there are different ports. Like there are multiple ports we can say. So for example, take a port of 8000. Okay, no, let's take example of 6000. Okay, so this is a port present in my Mac machine. So during port mapping, what I will do, I will saying that whenever I enter a port of 6000 in my Mac machine, it will be mapped to the port of 8080. है ना? So this is like that. So whenever I hit, for example, in my Mac OS localhost 6000. So what it will do, it will redirect to this port 8080. It will redirect to this port 8080. Okay, 8080, like I can say 8080. But will this accessing of this port 8080 will this be used to access this server? No, because this server is exposed in the port 8000. So what we need to do, we need to expose the container port 8000 here. Okay, 8000. Then we need to port map during running of the container. Like map my 6000 port which is running on my machine to the 8000 port which is running on the container. And this 8000 port is getting the information of the server, okay, which is running inside the container only. So this is what is port mapping, and this is why we need to expose the ports. So this is why I have written port expose 8080. Like this image, wherever the this where in which in wherever container this image will run, this will export the port 8080. This image will export the port 8080 into the container, and we are running the unicorn and we are using this port 8080. So it's like we are saying that okay, our fast API is running on 8080. Okay, our fast API is running on 8080 and our container port is exposed 8080. And so what we will do during the building of the image, you will see further in the session that I am going to map the running of the container, and I am going to write a code to map the 8080 port of the running machine with the container port 8080. So I hope you got why I have written this 8080, and I am running this fast API command using unicorn, and then saying that okay, run the fast API command and expose this port 8080. Okay, so like that we have created a Docker file. So what we need to do now, we have created a Docker file. We need to build the image and we need to test it locally. So for the sake of limited time, I'm not going to tell you that, but I'm going to guide you that how you can do it. And after that, we will move to deployment into the AWS. Okay, on the ECR, on the ECS. Okay. So what you will do, you will test the you will run the image. Basically, you will build the image using the Docker file, and then you will run the image using a Docker container, and then basically you will build the image from your current project repository, run the image inside a container, and build a Docker image, and then run the image. Like here you can see, we are during running, what we are doing, we are saying specifying port mapping using this flag dash p, and we are saying that okay, map the port 8080 with the container port 8080. Okay, and we are saying that run this Docker container. This is a Docker container name. So this is done. And now what you need to do, if you build a image using this Docker file, and if you run the commands properly, if you successfully run this command properly and your application is running perfectly, then what you need to do, you will need to deploy it. So we are going to this step, like we are going to deploy this Docker image. We are deploy this Docker image of our project into the AWS. So how we can deploy a Docker image into a AWS? So what is the process of it? So for it we use ECR and ECS. So what is this ECR and ECS? So ECR is basically, it stands for Elastic Container Repository. Elastic Container Repository. Okay, and there is something called ECS, and this is called Elastic Container Service. Okay, so Elastic Container Service, think of it like it's a space given into AWS, or a computational power given into AWS, on which you can run ECRs, like Elastic Container Repositories. Like this is the ECS given in the AWS. This is our ECS. Okay, Elastic Container Service. And what you will do, you will run this ECR inside this ECS. Okay, so what will this ECR? This is Elastic Container Repository. So like we have GitHub and repositories. So what is contained inside the GitHub in a particular repo? We have code. So likewise in our ECR we have Docker images. So what it's like, so it can be analogous to, we have Docker images and we have containers. So we will run this Docker image with the help of ECR, okay, in the ECS. So ECS is like a container which is given into the AWS. Okay, so ECS allows us to run Docker images into in AWS. So this is done, I think. So why I have written this Fargate here? Like what is this Fargate? So in ECS, basically in ECS we are running an image, but ECS is basically a server itself which is running a Docker image on it. So we need to configure the server by ourselves. So Fargate is the serverless way of doing the same thing. Like we don't need to take care of any optimizations or any server configuration. The server configuration will be done automatically using the Fargate. That is analogous to like if you have used EC2 in AWS. So there is two things like EC2 and Lambda functions. So in Lambda functions, what we do we have this EC2, like we have EC2, and there is the other thing like Lambda function. So what we do in EC2, we basically do everything by ourselves. Like if you want that please from now I want to increase my computational RAM to 16 GB from the previous of 8 GB. So we need to do it accordingly. Like we need to say that okay, my user base will going to increase. I need more computational power. My website traffic will going to increase. I need more computational power. So I need to go manually inside AWS, and I need to manually increase the RAM or the computational power by myself. But in Lambda function, what AWS says to do, give us a single function like func1. Okay. And if your traffic, if the traffic in your website increases and they use this function a lot, then we are going to automatically increase your CPU, your computational power. So this is what is called serverless. You don't need to take care of any server configuration. So similarly, we have this ECS Fargate. So in ECS, we have two ways to do things. In ECS, we have two ways to do things. The first is EC2 way, like EC2. ECS will use EC2 in the backend to run our Docker images from the ECR. But there is other way which is called Fargate. Fargate. And what is Fargate? Fargate is a serverless way of doing the same thing. Like AWS says us, just give me your Docker image. Just give me your Docker image with the help of ECR, Elastic Container Repository, and set the configuration to Fargate while deploying it into the ECS. And I will handle all the increase in computational and other server configurations. So this is a serverless way of running an ECS, of running a Docker image using a AWS container. Okay, so you can say that. So, but if you choose the EC2 way, what it will a manual configuration. It will require manual configuration of EC2. So we are going to use Fargate here. So I hope you got the understanding that what is ECS, what is ECR, and why we are using it. So let us understand it more with the help of a simple flowchart we have here. So as you can see, let me tell you some more things. Like here you can see that in ECS we have two launch type like Fargate and EC2. So in Fargate, AWS manages everything, and in EC2 basically you manage the EC2 servers in ECS. Okay. And what is the architecture, like architectural example? Like for example, here you have EC2 ECS cluster, like group of all the services like containers you want. So in ECS cluster it will be present. Like on what is task definition? This thing I will tell you during the during the coding. Okay. So let us understand it, what infrastructure of the AWS we will need to deploy it, and what files we need to create in our project. So what we will require to create a aws.yaml file inside our GitHub workflow, a task definition.json. Okay. So like these two files majorly we need. So what is this aws.yaml file? It basically triggers the AWS commands from the GitHub Action server. So this AWS YAML will need it for that. And the second is task definition.json. So by this task definition is like defining the configuration and all the task related details to deploy our Docker image of our project into the ECS. So for all this definition and configuration details will be written inside this task definition.js. Okay. And what is this? What infrastructure we are going to need in our deployment? We need a ECR repo. We need an ECR repo, so we will create that. Then this VPC will then the VPC will automatically create it, and this internet gateway will be automatically created, and this ECS cluster we need to create ourselves, so we will do that. Then this task definition I will provide you as it is. You will need to do some changes according to your AWS configuration. I will help you with that, and then you are ready to go. And then there is this ECS service, and then then it's a good practice to create a IAM role during deployment. You don't it is not recommended to do it using your root user. And there is security group. So security group is for allowing the basically ECS cluster into a public IP. So for that we use security group. So let us go ahead and do the things actually into our project. So in our github we have workflow directory. In this we have ci.yaml. So we are going to create two new files. The first is aws.yaml file. The first is aws.yaml file. Okay. And the second is task definition. Let me firstly create a aws.yaml file. So here is our aws.yaml file, and let us understand that what is written here. Okay. So let's go. And here you can see that this is basically a workflow file again, and here its name as CI CD to ECS. Basically we are sending our Docker image to the ECS Fargate. So I have said that okay, run this workflow whenever my CI workflow is completed. So this code is written for that, and then I'm setting this env like env variable. So here you need to change the major things, like firstly you need to see the region and you need to change it. So I will use US East 1, as you need to change this region accordingly. Then you need to change this ECR repository name. So I will change it, for example, ECR repo live. Then this is a ECS service, like ECS service name you have to change also. So I am changing it currently also to live. Okay, I'm just adding this live flags here. So in here we have ECS cluster name. So this is basically we are setting all the environments environment name which will be used in the further workflow code. So here I am done that, and there this is ECS task definition, and we are pointing out to that it is currently present in this workflow directory. So let us create the task definition.json also. So as you can see, I have created a task definition.json, and I will explain you this task definition.json in a while. So let's go, and we have configured this ECS cluster. We have set this task definition.json, and this is a container name. This is a container name of on which the image will run. Let me add a live also here. Like we are live, we are doing. Here we are setting the permission that ID token write and content read. This is required to for the communication related to the AWS and CI/CD. And then other here is what I'm doing. I'm just checking the status that is the workflow is run or not, and if it is successfully ran and we are currently on the push event, then we are going to what we are saying today, saying that okay, our CI passes means the CI workflow is passed, and we are proceeding to build and deploy. This is done. The first job is done, like checking the status. The second is the main job, like build and push. What we are doing here, we are building the image first, Docker image first, and then we are pushing it to the ECR, pushing it to the ECR. So what is the step here? Like we are first checking out the repository as always. Then we are configuring this AWS credentials. So for this configuration, why we are configuring this AWS credentials? Because the GitHub Actions server is required some credentials of your AWS account, so that the GitHub Actions server can communicate and perform some operations on your AWS account. So for that, what we need, we need these three things, like AWS region, which we have already set inside this env, and then we need this AWS access key and AWS secret access key. So we need to define this inside the GitHub secrets. So let's go ahead and define it. So as you can see, I am in the in my GitHub repository currently, which is LLMOPS series. And how to define your secret credentials? Basically, you need to go into the setting tab, and then here you can find in the security secrets and variable. Inside this, go to the actions, like GitHub Actions configuration, and you need to define this repository secret here, like by going to the new repository secret, and you need to go here and add the name, like the same name which is defined in this AWS, and you need to define this AWS access key and secret key. So where you will find this AWS access key and secret key, to define it here, you need to go into your AWS account. So let us go into our AWS account. Yeah, here it's my AWS console, and what you need to do, you basically go to your IAM here, IAM role, and then what you need to do, you need to go to this user here, and you need to create a new user. Like I am creating LLMOPS live here, live. So this is a new user, I am creating, and I am going to copy this permissions from the existing user. But what you will need to do, you will need to define the policies directly. So I will do the same for you, and I will give you the list of the policies you need to uh, attach into the user. So let us see the list. Like for example, if I use this as it is, and we will see the list here. Yeah, so what you will need, you will need this list. Okay, yeah, allow ECS logs, and also how you are going to add this. So let me see, let me tell you. So what we will do, we will create a new user from here. I am giving the name like LLM ops live here. Okay, and then what I will do, and I am going to attach policy directly. And what policies we need Amazon EC2, Amazon EC2 container registry full access, container registry full access. This one we will need. And then what we need ECS full access, like this one we need. And then what we need S3 full access, this one we will need. And then what we need CloudWatch logs full access. Yeah, this one we need. And then what we need secret manager, SECRETS secret manager, read and write. This one we will need. Okay, so how much is done? We have basically used 5 policies. Okay, and we also require 2 custom inline policies, which we will create later in the code, later in the session. So let's for now, let's go ahead with this only, and then create the user. Done. So we will need 2 more policies to create here. So here currently it's that, and now let's create 2 policies also. The that is custom inline policies. All the code you will get inside the description. So let us, yeah, so I will going to use this custom inline policy. I am just adding this in the actions, and then what I'm going to do, I'm just going to do the next, and then I'm going to give this policy name, the same policy name. I'm going to give this name, allow ECS logs. Okay, so this is done, and let's create it. So allow ECS logs is done, and now I'm going to create another inline policies, and I'm going to use JSON here, and then I'm going to write the code, the JSON of the custom inline policy. So this is it. So let's create, go and let's see next. Okay, and I'm going to name it allow secret access. I'm going to create it. So let me verify the name, allow secrets access. Yes, it is right. So our creation of IAM user is done, and now what we need to what we need to do is we need to store this ARN. Okay, we need to store this ARN and make a note of it. So I am copying this and storing this into our notepad, and we need to create a access keys for it. So you we use this use case command line interface. I will click on I understand, and then I will just skip this, and I will get this access keys, right? So this is your confidential access keys. I will disable it after this session. For the sake of understanding, I will given you. So this is the keys which we need to be used inside the GitHub secret credentials to allow the GitHub to be communicate with the GitHub to communicate with the AWS. Okay, so we have done, and we have this access keys present. So now let's go again to the GitHub, and let's create. So what your job to do is, like, you need to create this repository secret, and you need to paste the secrets you have created from the AWS of the IAM user into the GitHub action secrets repository secrets. And now and what then again what then? So then this secrets will be automatically read using the GitHub secrets, and then our this step is done. Like we have done what we have done, we have configured AWS credentials. Now what we do, the GitHub will log into the Amazon ECR using this configured actions, and then what we are going to do, we are going to build and push the Docker image, which we are which here all the configuration of that is written. Okay, so this is also done, we are building, and then what we'll do, we are going to build deploy the image. We are going to deploy the image in deploy the image to the git we are going to deploy the image to the GitHub. We are going to deploy the image to the AWS ECS. Okay, so this code is basically doing the same, like deploying. This is a new job at all, which is deploy to ECS Fargate, in which we are checking the repo as always, and then we are configuring the AWS. Then we are rendering the task definition. So here the task definition is using to configure the ECS, so that our image of our project present in the ECR can be used into the ECS. And then we are running the final job, which is done, like our code is deployed successfully to the AWS using ECS. So this is done. So this AWS YAML is done, and now let's do some configuration inside the AWS console so that our job will run successfully. So let's go ahead into the AWS, and what we need to do is you will need to do it with myself, like follow me. So firstly, we need to create a ECR repository, ECR registry. Here we need to create it, and I am naming it LLMOPS. I have to name it exactly same as I have named it inside this AWS.yaml. So what I have named our ECR repository, I have named it this LLMs repo, LLMOPS repo live. So I will use the same, and I will use it here, like here. Okay, and I am saying it's mutable. Keep it as it is. Just use this scan on push and just create it. So this repo will be created successfully. Just take a note of this URI, and you need to use this URI inside the task definition at in the last. So take a note of it, like I'm taking the note, like ECR. So I have to take the note. Now what you need to do, you need to go to the ECS, and you need to create a ECS here. Like you need to create a cluster, and you need to create the cluster name same as we have chosen here, like cluster LLM ops live cluster. Okay, and then what I need to do, I will just go into the infrastructure, and this see that this AWS Fargate serverless is already selected. Like here we can see pay as you go, like use if you have tiny batches. Like for I have already explained you this, and just create this cluster. Now in this cluster, we need to create a service where a task definition will run. Like in the service, in the cluster, in the Elastic Container Service, there are multiple services in which a task run. So the task definition we are going to create and understand. So in this cluster, we need to create a service. So for this service, we need to define a family. So in your AWS console, this LLM of STD will not come. So it will come after a step. I will tell you. So our next step is that. So before that, what we need to do, we need to run our deployment once. Okay, so what we need to do, you need to push your code, like you need to push your aws.yaml and aws.yaml and task definition.json once into the GitHub code, and automatically your workflow will run, and you will get this task definition.json when you will create this okay LLM of STD. For this, let us understand the task definition of JSON and do that. So here in the code, I have this task definition of JSON, and here what I need to what I am basically saying, I am just configuring all the container related code so that it can easily run our image. So here what I am saying, okay, the family is LLM of STD. So I am going to replace this, and I am going to replace told that okay, this is live here, and then I'm just saying that this network mode and all the configuration, this execution role ARN will going to be changed according to your IAM role. So from where you will get that, you will just need to replace this code, this with your IAM ID. Okay, so currently this is same as my IAM ID. Let me check. Yes, so you just need to replace this numbers with your IAM ID, and then I'm saying that okay, run my build in the Fargate, and then use this CPU, use this much memory, and here is the container definition, the Docker container definition. I am saying that the name will be LLM ops container. So I am going to use a live flag here, LLM ops live, and then here is the image, like here image where we are going to we have stored the image in the ECR. Okay, in the ECR. So I have told you to take the note of your ECR repo location. So I am just replacing the ECR repo location ARN here. Okay, so where you will find this, we have created the EC. Let me go ahead and create a new. Yeah, here you can see we have created a repository, right here. So this URI you need to use here in the task definition of JSON. So it will just point that okay, this container will use this image which is present at this location, and the CPU requirement is this, and then we are here we are doing this port mapping which I have told you already, like the container port is 8080, the host port is 8080. So okay, and the protocol we are going to use is TCP, and the name of this is this container, like the name of this container will be going to be LLM ops container. So this should be same. So I am going to do this, and this is done. App protocol will be HTTPS, and then I'm saying this is the environment configuration. So this is done so that it will the running code inside it will know that this is an production environment. So our model loader and all will know that this is a production environment, and we need to use the respective keys, and here this is secrets. So we have to store our APIs keys of the LLMs and all inside the AWS secret. So we need to store it, we need to store the secrets somewhere in the AWS. So where we store it in the secret manager. So let us go to the AWS and create a new service of AWS, which is AWS secret manager. So go to secret manager. Yeah, here this is a secret manager, and here you can see this is I have already created a API key live class. This is my secret manager. So what you need to do, you just need to create a new secret, like going here and just create a new secret here, and like choose this other type of secret, and just give the key value pair stored in your env, and then just go to next, like for example test and the 123, and I will do next, and here you have to give the secret name. So I have given the secret name API live class, so I have got that. So I'm just going to give test here, and then I just need to go to the next here. Okay, and next, and then as you can see this secret manager, and the name will be written here, and our secrets will, and you can also access it using this sample code also, and I will say store. So after a while I will see that open API live class test will see, and how will you check that it's storing the your key, like you need to create press this retrieve key, and you will see this keys. So how the AWS will know I will need to use this key, not the previous one, not other. So it will locate it using the secret ARN. So what you need to do, you will just need to copy the secret ARN and use it inside a task definition. So it will be used to configure our project Docker container. Okay, project container. So I have done the same for my APIs key which are already created. Okay, so here you can see this API key, this ARN I have already stored in my task definition. So this configuration is done, and there is this log configuration, like we are using CloudWatch logs inside the AWS. So we are configuring this. Okay, keep the log group as ECS LLM of STD. So I will just change the name to live also, so we can see also that is it running or not. So I have changed my task definition accordingly. You have to do the same. And now what you need to do, you just need to commit your code. You just need to commit your code inside the GitHub. Okay, or your any GitHub client, Git client you are using. So what we are sending, we are sending this Docker file, we are sending this AWS.yaml, CI.yaml already. Like I have made some changes which is not mandatory to do, and we need to do this other changes also. Here you need to go inside this utils, inside this config loader, and you need to just remove this multi-doc chat. Because why we are doing that? Because in our Docker file, we have already told that we are our full code inside this multi-doc chat. So during the running of the code inside the Docker container using this image, which is created by the Docker file, multiple times multi-doc chat will be called during the calling of this config loader. So that's why I have removed this code. Okay, so this is done, and now let's commit this code and sync. Okay, deploying to ECS, and let's commit it. Okay, I need to publish this, and this is a teaching ECS like branch. So I need to create a pull request, and I need to compare that, and I will create a pull request into the main branch so that our code will run into the main branch itself. And I have made some changes. Yeah, no conflict, and commit the merge, and the branch is successfully created. And as you can see, we have the recent pull accordingly. Our GitHub workflow will going to be run. Our test workflow will run first, and then after that our ECS workflow will run. As you can see, it's done, and now you can see another job is created. These are the previous jobs which are created. So as you can see, the CI/CD to ECS workflow is created. So as you can see, the image is building, and it will going to push to the into the ECR. So this will take some time. It will take some time. So as you can see, the building and pushing of the image is done. It took around 1 minute for me. It took around 1 minute for me, and then all the other jobs are done. And now here you can see this deploy to ECS has ran, and this failed at this deployed to ECS ECS task. So why it has failed? Let us see. It has failed by saying that okay, LLMOPS service is missing. So we are creating the service. We are creating the service into the ECS. So we have not created that. Why we are not able to create that? Because we don't got the task definition there. So we have ran this here, and I'm sure that we will got the task definition in the AWS console. So let's go to the ECS. I am currently into the ECS, and here I have created this cluster by myself. And now let's create the missing service by which the code by which the deployment has failed. So create this missing service, and here you can see I have this task definition now, which we have created, this LLM of std life. So I will use that here, and I will use the service name exactly same as it is defined in the task definition. Otherwise our deployment will going to be failed. So I will go in here, and I will use the exactly same service name which is defined in our aws.yaml. Okay, so here I will use the same service name, and other things you have to keep it as it is, and you just need to create this service. Okay, so in a while our service will be created, and then what we will do, we will just rerun the job which has failed. Okay, so it will take a minute. So we have created a service successfully, and now let's rerun the job which got failed, and see that if it runs successfully or not. So let's see into this workflow files. Okay, into the workflow, and now let's see the failed job. Like here, yeah, here this was failed, and now let's just rerun all the jobs. So as you can see, we are checking the status, and the status will just check that if the previous previous test and all are run or not, and we are on the main branch or not. Because if we are not on the main branch, these commands will not run, like the workflows conditions and all will not run, and our building and pushing of the Docker image has started. So now let's wait for a while. This will take some time. Okay, so the building and pushing is completed, and we have successfully post login, like remove the login and all, and clean up. And now we are in the deploy to ECS Fargate step, and we have rendered the task definition. Now the deployment is running, and as you can see, now it is not giving us the error, like the service is not present, because we have already created a service now. And now we can also see the status in the here also. So let's go to the AWS. Where it was it? Yeah, and here let's paste it and see what is happening. Firstly, okay, so that was the previous basically status, and currently we are on the deployment to ECS, and it will take some time. It will take some more time, like it will take around 4 to 5 minutes in general. So let me wait and let meet again. So as you can see, it took me around 4 minutes and 7 seconds, and the deployment to ECS is completed. and our post AWS configuration completed. So let's move on to the AWS console and see if the deployment is running or not. So how to check? So you just need to go to the basically ECS console, then go to the current cluster. Then you just need to go to the LLM ops live service with the service we have created, and now you can see the CPU utilization and all. Okay. So in here you just need to go to the task. It will contain the current task definition task which we have created using the task definition.json, and here you just need to go inside this task and you just need to open this public IP. Okay, and if you don't have the public IP, you just need to create an elastic IP and use this public IP. So if you open this, it will not run because we have exposed the port 8080. Remember, so I need to write this 8080 port, and after that, boom, successfully we see the project into the running inside our AWS. So let's check it and if see if it's running or not. So here I can see I will choose this file and I will upload index it. So as you can see, our indexes is completed and it's saying you can chat now. So I have uploaded the agentic AI.txt, which is contain the basic information of agentic AI. So what is agentic AI? I will ask and I will send it. So as you can see, it is giving me that agentic as a new paradigm, and it is based on the file I have uploaded. Because if I ask that what is phases of agentic AI development, yeah, for example, I ask this. So as you can see, just told me that phases is planning, and then there is learning, and then other things. Okay, so perception. So let us check that is it based on that or not. So as you can see, this is the agentic AI.txt, and in this you can see that the phases are like perception, planning, and then there is other things like learning and all. Okay, so it is based on that, and it is giving it based on that, and this is a simple RAG architecture, RAG. So you can improve this performance by using other methods, re-ranking and all. So this is the basic flow that how to deploy your end-to-end LLM ops application, LLM ops application into the AWS using ECS Fargate. So our last agenda is remaining, like you need to clean up all the deployment you have done if you don't want to use the project into the cloud, because it will cost you some amount of money, which is not which is a good amount. Like ECS cost us good amount of money. So if it is not used by you, so you should clean all the clusters you have created. So I will guide you with that. So firstly you need to go to the AWS and clean up with me. So firstly you will clean this ECS cluster. So go ahead, go open it, and then just delete this cluster and write delete LLM ops uh, live cluster. Okay, and just delete it. So this will take some time and it will delete it. Okay, so after that what we need to delete. So why it is deleting? Basically because we have already opened it here, we need to close it, and then we will delete it. So firstly let's delete ECR. Okay, ECR, let me delete it. It is uh, I will select it, I will delete it. Yeah, okay, it is deleted successfully. Now let's go to the ECS here, and now I will just delete it. Okay, delete this cluster, delete mouse live cluster. Yeah, done. So as you can see, the deletion is successful. So we have deleted the ECR, ECS, and what we have created the other things. You don't need to delete the IAM user; it will not cost anything. You should delete this secret managers, like here, all the secrets you have created, like this. I will delete because I don't need it now. So I will go and just delete it. Okay. So you should delete this also, and the other is like you must go to this EC2. Okay, and if there is any EC2 instances running, even after deleting the cluster of ECS, you should delete that, otherwise it will cost you money. And then the other is like you have to go to the CloudWatch and see if there is any log group, and if there is any, just delete it. Delete. Yeah, we have deleted the log group also, and yeah, I think we are done, and the VPCs are not needed to be deleted that much. So we don't needed to do anything else. So now your AWS is cleaned up, and be aware that you don't have anything else running in any other locations. So for example, you created anything in AP South 1, and you have created anything all else also, like you have, for example, you have created a ECS in AP South 1 also and US East 1. So this ECS will count differently. So if you delete ECS service from US East 1, it will not delete from AP South 1. So please take care of that. And if you have created any other services in any other locations, so please delete all of them. Okay, please delete all the services which I have told from all of the locations, if you want to, if you don't want to use it, and if you don't want any unnecessary AWS bill. So I hope you got to know how to like use this how to basically deploy this end-to-end LLM ops application inside this inside the AWS ECS, and you got to know that what is Docker and how to use it, and what is basically ECS and what is Fargate and how to deploy it. And all the steps I have taken, you will get a file with all the steps which I have done into the description, and I will also share the GitHub repository link inside the description. So I hope you got the complete understanding of how to create a LLM of application to how to deploy it. So thank you very much. Take care. Bye bye.